We're kind of on a fact-finding mission here with the 2005.9 liter Magnum engine. First of all, we have an 1.25" socket with the long bar so that we can turn this thing around. We have the valve train installed just for number 1 cylinder only because we want to read the cam profile. And we're going to read the cam profile to find true top dead center and our timing properties of this engine here. I want to find the compression stroke first, so we're going to turn the engine over until we feel compression coming out of our hole on number 1 cylinder. Now we know we're in the correct stroke. We can put our tool in there, and that is a tool that I built with a push rod, and that goes to the dial indicator so that we can know for a fact what our true top dead center is, because that's going to read very accurately the piston going up and down inside the bore there. The tool is simply a push rod that rides off the top of the piston, and then on the other end we're going to measure its movement with that dial indicator. I've done a previous video on how I built this tool if anyone was interested. We're finding true top dead center, so we found our compression stroke, and we went a few times, like probably 3 or 4 times over. I would slowly turn the engine over until I found the maximum lift on our push rod for our top dead center. And then I would go back and I would do it repeatedly and adjust the dial indicator until I was satisfied that we finally found our mark. When we put a ruler up against our timing mark here, it looks like we're at about 2 degrees. 2 degrees off top dead center. In all honesty, at top dead center, the dial indicator read 0, and then it hung at 0 until we've got to this mark right here. So that's about 2 degrees. So it's kind of hanging at 0 for 2 degrees. So if we divide that by 2, then our true top dead center should be 1 degree. Now when you take a look at the dial indicator, you can see that it's starting to come back. So it was going up and it's just starting to come back there, and that's how I got that 2 degree mark. Now when we take a look at our timing marks here, we want to notice a couple of things. First of all, we've got timing marks on the timing chain cover, and then we've also got timing marks on our harmonic balancer. Now we got to take a look at this like in the relationship of a mirror. So the way I look at it is we've got top dead center on the timing chain cover. Anything this way is going to be retarded, and anything this way is going to be advanced. Now if we take that mirror concept and we start using this, now it's going to be the opposite. This is going to be advanced and this is going to be retarded. To try and explain it a little bit further, we had our ruler right there, and we were reading the 2 marks off of the timing chain cover. But if we put our ruler right here and we line it up with the timing chain cover TDC to the harmonic balancer, that's going to be 2 degrees on here. So if this is retarded, then this is retarded. And if this is advanced, this is advanced. And this is why you have more timing marks on this side of the line than on this side of the line, because you're going to be advancing your timing when you set your timing. Having said all that, it's almost redundant because you can't set the timing on a Magnum engine. The timing is all set by the ECM or PCM, whatever you want to call that thing. There's a bunch of sensors on the engine that will give that thing data, and it's going to be temperature sensors, mass air pressure sensors, mass airflow sensors, camshaft position sensor, crankshaft position sensor. All of these things will give information to that PCM, ECM, and that thing then will run within its calibrations to keep the engine running. So if you were to put a timing light on here as this is running, you're going to see this thing moving all over the place, and therefore you can't set the timing. I have this idea of setting initial timing on this engine, and then the computer then does its thing after the fact, because that's really the only option or the only availability that you have with this engine. With a carbureted engine, you would adjust your distributor back and forth, and that would help set your timing. As you're adjusting your distributor, you would notice the timing light with the mark changing on your timing values over here on the front of the engine. Now you can't do that with this Magnum engine because this isn't your standard distributor. In here, this is the camshaft position sensor. Full disclosure, this is not the correct one for this engine. It's just here for demonstration purposes. When you install this, you're going to install it with the rotor supposed to be facing number 1 cylinder, but in fact there's going to be a mark on this plastic plate, and you're going to line up your distributor with that mark. Now, if you do move this thing side to side, you're not adjusting the timing, you're adjusting the fuel trim or the fuel sink. Forget about the distributor, it has nothing to do with the timing or what we're trying to achieve today. This is the crankshaft position sensor, and this is the magnetic pickup. As the flex plate turns around and around, you see these little slots in there, and that's going to be where it's like it's got connection, breaks connection. And when it breaks connection, it's going to fire your spark. So right now, if we take a look, this is at true top dead center. And take a look into relation to where the sensor is and where our firing is of the spark. Now, my theory is we can adjust this sensor back and forth to change or alter our initial timing. My theory is that we can adjust that, and then the computer will then do its thing afterwards. Now, we might only be able to change it by a maximum of 4 or 6 degrees, but still, it should make a difference. What I want to do on this end is I'm going to advance it until I have that sensor in the back showing where the spark is firing. And we want to see how many degrees advanced that's going to show us on our timing scale here. Each one of those marks on the vibration dampener are 2 degrees. We're almost at 8 degrees, but not quite. So we could call it 7 degrees advanced is when the spark is firing. On this side, I have some reference marks on the crank position sensor. So that center of the sensor is lined up with the center of that hole in the flex plate. We could manually move this sensor, and we could position that to say 10 or 12 degrees advanced. If we remember that our true top dead center was 1 degree retarded, we have to subtract that from our 7 degrees advanced, so we're only actually 6 degrees advanced. I looked up a catalog of recommended initial timing and advanced timing curves. Now, these would all be based on an LA engine, but it's the same principle given it's the same engine. And the values started off at a baseline of 10 degrees starting point, and then they went as high as about 23 degrees. Now, that's initial timing. But once I took all those factors in and I got an average, the average is about 15 degrees. In theory, if the average is 15 degrees, and we were shooting for 15 degrees, that leaves another 9 degrees that we can adjust this thing and see what kind of performance upgrades we could get. I've adjusted it to the maximum of 20 degrees advanced here, and we'd take a look on the back and see what location that puts us for that sensor. This is the difference it's showing in the back here. Remind you that our original mark on the front was 7 degrees advanced, actual 6 degrees, and this would be 20. So that is our variance in there. Here's a look at 15 degree mark on the front, and then we'll adjust it to say a proper 10 and see how much difference that's going to show us. So that's set up for 10 degrees advanced, and that's also factoring in our 1 degree retarded. So this would be the actual 10 degrees on this engine advanced, according to the timing marks on the front. I measured the distance between the center of that slot and the center of the sensor, and we've got just a touch over 400 thou on our vernier here. Now we just got to find a way to make this adjustable from its current timing mark to what we want to achieve.